to my computer and got the computer to just keep making boundaries, keep making smaller and smaller triangles, it would continue to do this to infinity until it heated up, melt down, and I'd have to go and get myself a new computer. But assuming it didn't do that, it would keep making smaller and smaller triangles to infinity. And I could give it a code so that every 5 iteration or 6 iteration, it would zoom in so you could see it again, and then starts making more triangles, and then zoom in, and then so on to infinity. However, although I can place an infinite amount of triangles, I will never exceed the first boundary I made for myself. Never. I just showed you how infinity fits in a finite space, or a so-called finite space. Because you can divide to infinity within the circumference of a circle. What does that mean? Why is that important? What does that do to your life? What does that do to the way we do things on this planet? Well, let me give you an example, even if it's just for physics. We built faster and faster and faster accelerators that cost billions of dollars to build, to get smaller and smaller and smaller and smaller. Now we're at like millions of times smaller than an atom particle, actually. And we're building accelerators now in Geneva, in Switzerland, that are costing $300 billion, I believe. 5 countries had to get together to build it, right? To get even smaller particles. Well, if we understand this principle, we would understand very quickly that you can keep building larger accelerators and you can keep getting smaller and smaller particles. You can always keep dividing. So we would give up the search for some fundamental particle and that's going to end the search for particles, and we would start to understand that what we need to discover is the dynamics of the division, the dynamics of the quantization. Do you understand? Not, how far we can go into infinity. Just so that some physicist can put his name on it and get a Nobel Prize for a new particle. But further, what does it mean to you? It means that if this is true, every one of your atoms, every one of your cells has infinite potential in it, has infinite connectivity to everything else. That each one of your atoms is a mini black hole. Because if there's infinite amount of particles in it that can be divided, that means it has infinite mass. Most people say, I can't envision infinity. If, it's a good point. You might have to take a lot of coffee in the morning. But it's like, I can't visualize infinity. If it's true that I have an infinite nature inside of me, how is it that I can't see it, that I can't visualize it? That's a good point. Well, the reason is that most people try to envision infinitely large when they think of infinity. So that is limited by your senses because it's external to you. However, here we see that through infinite division, we can generate singularity, a link to all other things. So when you try to visualize infinity, you might want to turn your senses inwards and go towards the infinitely small that's contained in all of your atoms, in all of your cells. Well, just happens that all of the masters that have walked the earth have been trying to tell people about turning their senses inward through meditation, prayers, and so on, to connect with their infinite nature. The Buddha, Jesus, all these people said the temple of heaven is within you and within everything. That's the description of a fractal, my friend. The thing is that it was never appropriately applied to physics. It has huge repercussions in physics because it completely changes the way we look at the structure of reality if everything contains the whole. So you see, already this is a key to understanding your nature and your potential. How many times in the year do you turn your senses inward and connect with your infinite nature? And so I was really excited about this because it seemed to say as well that the universe would be expanding and contracting. Right? If everything goes towards infinity at the center of all atoms, then the universe is contracting as much as it expands. And I could see how the external part of my existence is the expansive part, and the internal part of my existence is the contractive part. So I started to think in those terms when I was actually 11, and I learned to meditate. A young master of meditation from India taught me to meditate. And I was really excited because I was discovering a whole world within myself that seemed to have infinite potential. So I started to spend more and more time concentrating inward and connecting with that part of my existence. And I started to think that there must be a balance between the expansion of the universe and the contraction of the universe. And the contractive part of that balance equation is the part that generates. And the radiating part is the part that alienates, that destroys. Yet, all of our science, all of the knowledge is based on the radiating part. There's nothing we've really discovered since fire. We explode everything. We put fuel in a rocket, right? Tons and tons of fuel, and we light the bottom, put a few people on top, and pray that they're going to survive the experience. That's our approach. We put fuel in our car, and we explode it in a chamber, and we push a piston up and down. It's all about explosion. And we think the universe is expanding. When much later, I was brought to Georgia Tech to have a conference, kind of a debate with other physicists. These are very well-known physicists, highly regarded, older people that had their students there. And we were talking about things. Some of the students were there. They came in and out. We were, looking at equations. We had all this stuff on the big wall there, on the blackboard. And I showed up with this book. This is the only book I had with me. I had maybe another few, but that was my main book. It's called Gravitation. It's a classical book about relativistic equations. It's written by Messner, Thorne, and Wheeler. Those are legends of physics. Wheeler having worked with Einstein.